Okay, today we're going to talk about significant figures. When I went to school, we call them significant digits or sig digs, and now they've kind of been renamed to significant figures or sig figs. Um, when I was going through school, I didn't quite understand these, but now they make complete sense to me. I guess I'm just older. Um, we use significant figures to kind of in science we use all kinds of different machines and measuring tools, instruments I guess would be a better term, and so it helps us with a degree of certainty is basically what it does. So it says a significant figure or digit is a measured value that is known with certainty or can be reasonably estimated. So if we were looking at a ruler here, can't pull that down very well. If we're looking at a ruler that's blown up here, you can say, well, with great certainty, this is over 3 centimeters. It's actually over 3.5, and it's actually about 3.8, and it's a little bit past that, so maybe like 3.82. So we could kind of, with pretty good certainty, say 3.8 for sure, 3.82, but we couldn't say 3.825964. So there is a point where our instrument can't be very accurate. So when we get over to the lab, we'll notice that our scales can go out to decimal places. So we can't say something weighs out to the thousandth or the millionth place because our scales aren't that accurate. And so that's really where significant figures or digits have come from. And there are certain rules as far as how we're going to round numbers. So you just kind of have to go with the flow. They're really not that hard. They seem like real weird math at first, but if you catch on, I think you'll be just fine. Alright, rule number 1, and you won't have to repeat these rules, you just have to be able to use these rules, is first, anything that's a number that is not 0 is said to be significant. Alright, so that one's an easy. 243, we would say, has 3 sig figs. Or 3 sig digs, 3 significant figures, all 3 of them. That means whatever I was looking at measured exactly 243 meters. So our next one, a zero between non-zero digits, meaning real numbers other than 0, are also significant. So this 3 and that 6 is trapping those zeros in there. So now they're all 4 going to become significant. So we say that this has 4 sig figs. Okay? I keep wanting to hit that little, if I forget I'm in a different thing. A 0 at the end of a decimal number is also significant. So it's got to be after a decimal and it's got to be a 0. So these two are because of rule letter A. And this one's on the very end, so this one is, and this one is also now getting sandwiched between, well, that one says non-zero, but it really should be other significant digits, but really these are still zeros going on after, so this would have 4 sig figs here. Even if we had something like this, they all would count because of that decimal there. So all those are going to count. 1, 2, 3, 4, 5, 6, 7. That would be a very, very good instrument if you could go out that many decimal places. I don't think we've got any that good here, but that's okay. Alright, then we were talking about scientific notation. So if we have a number that's already in scientific notation, all of these that are in the coefficient are said to be significant. You would not expand it out, so you're not going to do the times 10. These zeros here are what we call the insignificant. Not that they're not important, it just means we had rounded that, we don't have a really degree of certainty there. So this would have 3 sig figs. And this is something called Avogadro's constant, 6.02 times 10 to the 23rd power. Alright, so there's ones that are significant. So let's see if we can talk about ones that are not significant. Talk about the zeros. Okay, so if they're beginning zeros, we call them leading zeros. And this one is probably the rule that I have the most trouble with, especially as a college student, and I was like, well, I don't understand that. Machines are very, very accurate. And they say that these are just kind of like placeholders, and that to really, if you want someone to really know that those are significant, you would put that in scientific notation. You would go 2.03 times 10 to the 1, 2, 3, 4, and it would be positive or negative since it's a very small decimal. And so then this thing would only have 3 significant figures. If I say digits, I'm sorry, because I'm kind of used to that. So these beginning ones are not considered significant. Those are, we don't start until we start hitting a number. That doesn't mean you don't write them, okay? Because I have students that will like, oh, well, they're not significant. We'll just change it to that. No, 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 no. We still want the value. So this is just going to be some rounding rules when we start getting into some of that math. So please do write them, because there's a big difference between .203 and .00203. Now this number and that number up there are the same. Okay. And then if they're a really, really large number and they have trailing zeros with no decimal, they are said that they're called placeholders, like it's kind of like I said up there. So even here, see, there's no decimal there, so this only has 2 significant figures here. I could put 5 more zeros and we would still say that they're just placeholders. Again, if you don't want to think about it too much, you could put it in scientific notation, 1, 2, 3, 4, and that would be to the positive 4th power. Okay, so these are called placeholders, or trailing. These are trailing zeros, and those are leading zeros. So we're not going to look at those. We're not going to look at those. Now, let's just do a what if. What if we had this? Let's say we had 3, and we go like that. Now, because of that, that thing right there is kind of important. These guys would all count. 1, 2, 3, 4, 5, and 6. This would have 6 sig figs. Okay? That decimal is kind of important. Now what are we going to do with these things? Well, we're going to be doing a lot of multiplying and dividing, adding, subtracting, and then rounding our answers, because our calculator gives us like really big numbers and we don't want all those numbers. So our first rule, and this is probably the most common one, is when we multiply and divide. When we multiply and divide numbers, you round your answers so that it matches your original problem to whichever had the least amount of significant figures. For example, we just got 5 times 2. 5 times 2, of course, is 10. But that's not the right answer, because we are looking for the correct amount of, look, I put digits there. It's the correct amount of significant digits. So let's look here. This one has 3 sig figs. This one has 4. So your answer needs to match the original problem, whichever was the least, and the least being 3. So I need this number to still be 10 and have 3 significant figures. So I would put 0.0. Crazy math, isn't it? Okay. So next one. When you add and subtract, adding and subtracting has to do nothing really with significant figures. It has to do with decimal places. And this would make so much sense. Let's just say we were dealing with 2 different scales, and we were weighing one object, and we'll just put some units there because it's always good to have some units. Okay, and one object weighed 2.353 grams, and another object weighed just 9.0 grams. We weighed them on completely different scales, which is not a good thing to do, by the way. One scale could only go out to the 10th spot. The other scale could go out 3 decimal places. So if we just put these numbers in our calculator, this is what our little calculator would say. Of course, the calculator wouldn't say grams. But you can't say with certainty that this one wasn't like a 1-1 and your scale just couldn't measure it. So it's a degree of certainty that you can measure, and you can only measure out to the 10th. It's kind of like you're only as strong as your weakest player, or our weakest player is this little scale that could only go out to the 10th. So our answer could only go out to the 10th, but we are going to round. So we're going to go to this place right behind it. It is a 5, so 5 or more we round up. So this would be 11.4 grams would be our correct answer. Okay, so that's pretty much significant figures in a nutshell. Hopefully this video might have helped a little.